solve a very popular problem, that is LRU cache. So instead of directly jumping into the problem and solving it, we should know what is cache is and how LRU relates to cache, right? So let's just visualize an image and understand. So in this image, we have application, we have database, we have cache, right? So what usually happens is when you send a request, your request gets served by your database because everything is in your database, right? But why do we need cache? Because you want to, so let's say there is some relevant information, certain information you want to like you want to serve this information very fast to your users, and it is very likely that you are going to use a cache because cache is an in-memory data store. That means it stores the data in the memory, but in database we store the data in disk, so it makes a difference while serving the data, right? But there is a limitation when it comes to cache because we talked about this is the in-memory data store. That means the memory limit is going to be there, so you are only going to be storing relevant information into the cache. You don't want any unnecessary information. So for that you need an algorithm which is known as policies, and there are different policies for storing relevant information into your cache. The first one is LRU, which is known as least recently used policy, and the second one is LFU, which is known as least frequently used policy. In this video we are going to talk about least recently used policy, but before knowing that, you should know why do, like you can literally use your own policy, but let's say your policy is not that great. You know uh, left some edge cases. So what happened is unnecessary information gets stored in your cache, and this problem is known as thrashing, which is like hurting you more than helping you because you are using a cache but you are not utilizing it in a proper way, right? So let's just jump into the question and see what we can do. This question is saying is that we have to design a data structure that follows the constraints of a least recently used cache. So we basically have to implement a constructor which is LRU cache, which takes input as a capacity and initialize LRU cache with positive size capacity. Okay. The next thing is the function get, which takes the key and returns if the key exists in the data exist. If it doesn't exist, we need to return -1. And then the third function is that is put. We put text input as key and value, and update the value if it is already exist. If it does not exist, then we are going to, okay, otherwise add the key value paired to the cache. If the number of keys exceeds the capacity from the operation, then evict the least recently used key. So what this basically is saying is that we have to implement two functions, that is get and put. So get function will basically do something like you will be given a key, and you just have to find whether or not, or like we just have to return the result of this key, obviously the value of this key, right? So for this put function, what you have to do is you have to insert this key value into your cache. But the thing is, if the if it already exists in the cache, you have to update the value, right? If it does not exist, you will be inserting into the cache. If the cache size is already exceeds, let's say your cache size is 10, and by inserting this thing into the cache size would be 11. That means you have to remove the less used data from the cache, which is actually the policy of this cache, right? So policy of LRU, right? So you have to evict the thing that has not been recently used, right? So let's just see an example, and you'll just understand what we are actually talking about. So the LRU cache, the input is LRU cache, which is 2, which is obviously 2 is just the size of your cache. That means let me just write over it and we'll just jump into the problem, right? So 2 is the size of your, obviously the size, 2 is the size of your cache. Then you insert 1 into your cache. You are inserting 1, okay? You are inserting 1. Then you are inserting 2. Then you are getting 1. That means 1 is recently used, right? Okay, we are just remembering it that it has been recently used. So now we are inserting 3. But how can we insert 3? Because we are size is already, like our size cache size is already 2, right? So what we can do is we'll just remove the less recently used data. That means 2 has not been used recently. That means we are going to evict 2 and insert 3. We are evict 2, and we are going to insert 3, right? So then we are going to get 2. Obviously we are going to return -1 because 2 is not there. So then we are going to put 4 into it. But how can we put 4? Because our size is 2 and 1 and 3 is already there. right? So what we can do is we will remove 1 because 3 has recently inserted into our cache. That means it is relevant to our cache, right? So 1 is not that relevant because it has not been recently used. So let's just remove 1 and insert 4 into it, right? So then whenever we get 1, we'll be returning -1 because it is not there in the cache. We Whenever we get 3, we'll be getting the answer. Whenever we get 4, we'll be getting the answer. So yeah, that's pretty much it, right? So how do we actually approach this problem? The first step for this problem would be, you should choose the relevant data structures for this problem, right? So the first step is choose relevant DS, right? So we are going to choose the relevant data structures for this problem. So why do we need actually we need different data structures to solve this problem. So the first thing would be to maintain this hierarchy, right? So whenever you insert some, how do you know for which information is relevant? You need a data structure for that, right? You want to know the relevant information, relevant data at each point of time, right? You want to maintain this hierarchy, right? So for that you will be needing one data structure. We'll be talking about which data structure do we need. And the next thing is for retrieval. So you need a data structure which can retrieve data very fast and efficiently, right? So for that, obviously this is obvious. For getting a key you need a hash table. So for that we'll be getting a hash table for getting the keys. So we'll be taking a hash map of integers, and value is also an integer, right? Just naming it map. So second thing is, to know the relevant information we will be using a linked list. But why do we need a linked list is that linked list is all about pointer manipulation. So what we can actually do is whenever we are actually so let's say we are talking about so let's say we inserted 1, we inserted 2, and we get 1. That means 1 is the relevant information. So what we can actually do is we will just take 1 from the linked list and put it at the beginning of the linked list, because putting anything to the beginning of the linked list is big of one operation, which is very efficient when it comes to linked list, right? So we'll be taking a linked list to maintain this policy. Linked list of integers, sorry, integer. I'm naming it as LRU cache. LRU cache. Then I'll be needing a variable that is capacity, which will use it as the cache limit, right? And capacity, right? So in this constructor, we are going to initialize all our data structures, right? So map would be an hash map, of integer as key and value, and the LRU cache linked list would be of integers, right? Linked list of integer. The third thing is capacity. So this dot capacity is equal to capacity. This is our cache limit capacity. This is our cache limit, right? So the next thing is get function. So let's just write pseudocode for it, and then we'll write code, right? So for getting the key, so first we need to check whether or not this key actually exists in our data store. So first we'll check if it is already exist. If it is already exist, then what we can actually do is, if it is already exist, then what we can do is we'll just get the information from the linked list and put that key into the front, we'll add that key into the front of our linked list, right? So that we would know that this information is recently used, right? This key is recently used. So what we can do is we'll just check if map dot contains, if it contains in a hash table. So what we can do is we'll just remove it from our linked list, obviously. LRU cache dot remove LRU cache dot index of our key, right? And after removing it, we're just going to add this key into the beginning of our linked list, right? LRU cache dot add first the key, right? So what we're actually doing is, if it is already contains, so what we can do is we just remove the key from the linked list and we are adding it into our into the front of our linked list, right? So now when we do this, if it does not exist also, so we have a condition that we'll just return the key from the map, right? Map dot get the key. So here we'll check if it is already exists. If it exists, we do this manipulation, and at our end goal is we'll just return the key from the map, right? So there is a case if it does not exist, we have to return -1, I guess. Yeah, we have to return -1. For that, I'm just adding a default value to it. Get dot default, that is -1. So what this function will do is we'll just get key if it is not there, so it will return the default value as -1, right? So for this put function, what we can actually do is the first thing we should check if it already exists, right? So if it already exists, so what we can do is if map dot contains key, if it is already exist, so what we can do is we'll just take the key from the linked list and obviously remove it and update it in our map, right? So the first thing is if it is already exists, so what we can do is LRU cache dot remove LRU cache dot index of key. We'll just remove it, right? And also remove it from the map also. Remove this key, right? So if it already exists, we are going to remove it from the hash table and from the linked list. So the next condition is if like our cache limit exceeds, so that means we are going to delete the like irrelevant information from the uh, LRU cache, right? So what is the irrelevant information at a given point of time? The node that the key that is in the last like that is the last element in the linked list is the irrelevant information, right? So what we can do is we'll just check if our capacity does exceeds our size of the linked list. So we can actually do is we're going to remove the last element. So let me just retrieve the last key as LRU cache dot remove last. So we're getting the key from we're getting the key which is the last element of the linked list, and we are going to delete it from the map also, right? Because how do we know which key to delete from the map, right? So that's why we retrieved the key and we're going to delete it from the map.remove last key. And then after this happens, we're just going to insert it into our linked list and our map, right? So LRU cache dot add first. We're going to add it into our linked list and add it into our map, key and value. So hope this works. Yes, this works. You can just submit it. Yeah. So yeah, this works. So if you like this video, just like and share, and see you in the next video, right?